Yeah, so we are on the Alcènes, and we are still on the nomenclature of Alcènes. So an alkene is a hydrocarbon with a double liaison, with a sp de hybridisation, and forms an angle over 120 degrees between its adjacent bonds, that is with hydrogen. Then we said it forms a shape called triagonal. Yeah. Then the simplest bonds are P and sigma. So the general formula for alkenes is CnH2n d'après la chimie organique des zombies. Then we are saying an alkene molecule has une molécule ayant plus d'une double liaison, ce n'est pas une alcène. So if it is having more than two liaisons, it's not considered to be, it's considered to be under the family of alkenes, but now we are going to look at how the orientation is going to be, because we are going to use the multiplication factor in this case. You get it? We're going to use the multiplication factor, which is going to determine the repetition of three double liaisons, the first one, the second one, and the third one. So we're going to use a multiplication factor that is going to be 1, 2, 3. If there are three of them, we said we are going to use the 3, which is this one here. This one we are talking about here. So the first principle, like we said, the first principle we said is when you're naming an alkene, is you count the longest chain. And the example we have here, when you count the longest chain, you're going to have 1, 2, 3, 4, 5, 6, 7. Rule number 2 is you look for the substituent. Now, in the case where you do not have a substituent, you go to the position of the double liaison. So like I said last time, I said the double liaison will always have preference if you have a double liaison and you have an alkyl group or bien any other substituent. The double liaison will get preference. This one will be the first thing you're going to look at. Then later on, you are going to give the position of the substituent. Now, in a case where you only have an open chain like this one, you only look for the position of the double liaison. Now, the double liaison in this case is found at position number 2. So when you count, it's the same rule. You count from this side and you also count from the other side. So when you count from this side, you have 1, 2, 3, 4, 5 at position number 5, and you have 1, 2 at position number 2. So it becomes hept, which is the prefix, then the position of the double liaison, and the terminaison. The terminaison. So this is called the hep de in. Then this one, same thing. You are going to count the longest continuous chain, which is going to have how many carbon atoms? 1, 2, 3, 4, 5, 6, 7, 7. The suffix or the prefix is a hep. Then the position of the double liaison is at carbon number 1, 2, 3, 4, position 4. 1, 2, 3, position 3. So 3 is the lowest index possible, and we are going to position the double liaison at position number 3, and the suffix of this compound or bien hydrocarbon is Ene. So this is going to be hep 3 in, hep 3 in. So heptane or bien hepta is the suffix for this one. Now we said if there is a vowel and a vowel that are following each other, you supprime. This is the reason why even for this one, you have vowels that are being cancelled. It all comes back to this here. Hepta with the A, Now, because you have two vowels that are in contact, if that's the correct English to use, in contact, we are going to supprimer one. Then I gave an example, or see, where you have a triple liaison. Now, for a triple liaison, you also apply the factors of multiplication. So you count. The first principle is counting the longest chain. You're going to have 1, 2, 3, 4, 5, 6, 7, 8. So 8, that's octa. Then you are going to also count the position of the double liaison, having the lowest index possible. So the lowest index possible, we are going to either start from this side and this side. So the first time we're going to say 1, 2.
Nomenclature confused.
Ati? Ajan? Someone was saying nomenclature has done what?
I'm saying it's just confusing some people, so I was just trying to
It's confusing
understand
you.
what you're trying to say.
It's confusing you.
It was. No, it was, but I wasn't seeing what you're saying. So I was like, oh, what is he saying? It's confusing me.
I should start afresh.
No, I just want you to explain the other last one. This one for octa something.
This is where I am. This is where I am. I'm not finished yet. This is where I am.
All right.
Yeah. Are there any questions so far? If you have a question, please ask, guys. Ask so that we are going at the same pace. If you have a question, ask. So we are saying the longest continuous chain contains how many carbon atoms? Contains 8. This is where we have the prefix octa. Then rule number 2 states we are supposed to look for the positions or look for the double liaison. Now, in this case, we have 3 liaisons. We have 3 liaisons. We have 3 liaisons. Now, these 3 liaisons are supposed to be given positions. Now, that's rule number 3. You look for the position of these liaisons. So, with the lowest index possible. Yeah, with the lowest index possible. So, when you start counting from this side, you're going to have 1, 2, 3, 4, 5, 6, 7. So it is position number 2, position number 4, and position number 7. That's position number 2, position number 4, position number 7. Let me just draw. Where is it? So at position number 2, position number, what is this? 4, and position number 7. Then we also count from, this is from our left to the right. So we count also from this other side to this other side. We are looking for the lowest index possible. So this is going to be at position number 1 prime. When you're naming this compound, you're not supposed to put 1 prime. The 1 prime is just to differentiate these numbers that are going to be in the ones that will be going towards the right, and those ones that are going to be going towards the left. It's just to show a difference, because if I just put numbers like that, it will confuse some of you. So position number 1, 2, 3, 4. At position number 4, we have another double liaison. At position 5, 6. Position number 6. So this is 6 prime, 4 prime. So on the left hand side, we have these indices. That's 2, 4, 2, 4, 7. That's on the left hand side. On the right hand side, we have that's 1 prime. We have 4 prime and 6 prime. So the lowest indices possible are these ones, because 2 is greater than 1, 4 is the same as 4, and 7 is greater than 6. So rule number 3 is we are supposed to have the lowest index or indices possible, and the lowest are these 1, 1, 4, and 6. So this is the position of the double liaison in this trienne. So we're going to say, okay, the prefix is octa. The positions, that is at position number 1, position number 4, this is position number 1. Just a minute. So we are saying at position number 1, position number 1, position number 1, at this position we have 1 at number 4 and at number 6. So at 1, 4, and 6 we have the triple liaisons. So we are going to position them in this order, say 1, 4, 6, and we are going to now use the multiplication factor. We are going to use the multiplication factor. Now the multiplication factor is 3. We are having 3 triple liaisons here. 1, 2, 3. There are 3 of them. So we're going to say 3 in obia train. So the position 1, 2, 3 will result in us having a try in. If we had 4 triple liaisons, if we had 4, maybe something like this, we're going to say, okay, this is position number 6, this is 7, this is going to be 8. So if we include 8, if it was 8, we are going to say tetra in, which is this here. For 2, we are going to say diin. For 3, we are going to say tetra. For 4, we are, oh.
One moment. The only option I found is clinic.
So, sorry. So for 2 double liaisons, we are saying we're going to call it a diin. For 3, we are calling it a triin, also known as a tris. Triin and tris is the same thing. Ou bien a tetra. Tetra in. So now, because we don't have what do you call them? We do not have vowels that are in contact. We are not going to cancel out this vowel here. So on supprime la terminaison A de la racine grecque lorsque il est suivi d'une voyelle. So that is the rule that justifies the voyelle. So now I want to talk about this. So an example of an alkene that is a alkene with a substituent. Is it clear for the other part? The triene, the is hep 2 in, hep 3 in, octa 1, 4, 6 triene. Is it clear here?
Yes, it's clear.
Okay. So this part is just the same as where we have a double liaison for an alkene. Now we always talk about alkyls, that is hydrogenless, hydrogenless, but we also have alcyls. Alcyls are hydrogenless of the alkene. So we won't talk about that. Just for you guys to know. So an example, just give an example. So where is it? So this is a it's in front. It's in front. Here. So we have what we are calling as alcyls. Alcyls are radicals with mwanza. The same principle, that is an alkyl is an alkene with one hydrogen atom less. An alcyl is an alkene with one hydrogen atom less. So we won't go much in detail. So the only radicals in your organic chemistry will be the alkyl, the alkene with one hydrogen atom less. So this is the example we are going to look at now. So we are saying principle number 1 is look for the longest continuous chain. The longest continuous chain. Now in this case, the longest continuous chain is this one here. 1, 1, 2, 3, 4, 5. So 5. Now we know that the smallest index possible for the double liaison will be the direction from our left. The lowest index possible will be from our left hand side. It will be from this direction, because when we count, we have 1, 2, 3 at position 1, 2, position 2, and when you count from the other side, it will be 1, 2, 3 at position 3. So 3 and 2, 2 qualifies to be the lowest index, and this is our 2 here. Then the ending is ene, that is the suffix of the alcenes. Now we are also going to look at rule number 2 that states we are first supposed to look at the double liaison, then later on define where the substituent is found at. Now, fortunately enough, the substituent and the double liaison are found at the same position. So this is position number 2. So when naming any organic compound using the UPAC nomenclature, we always start with the substituent, then we go to the parent chain. The parent chain is the chain principal. C'est la même chose. So now this here is what we are calling a methyl substituent. It's a methyl substituent and is found at position number 1, 2. This is the 2 we are seeing here. And the position of the double liaison is also found at position number 2. And all in all, the carbon chain here, the longest continuous chain, has 5 atoms of carbon, and we are calling 5 a penta. A penta. Now, if it's called a penta, we are supposed to cancel out the A here because there is a vowel here and there's also another vowel here. So there is going to be the cancellation of this A here because there is this ending here for ENE. So therefore, the name or the nomenclature for this organic compound would be 2-methyl pent-2-ene. It will be 2-methyl pent-2-ene. Any questions on this one? Any questions on this one? Any questions? Okay, if there are no questions, we go to this one. So when you have a double liaison that is drawn like this, don't be afraid of no, Shani, no. It looks different from the normal ones. We look always, when you have a double liaison, you take it as priority. So when counting, we are going to start from the double liaison. So now the longest continuous chain always start from the double liaison. So we are going to count either 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So our longest chain is this here. This is our this will be our longest chain. The rest become substituents. The rest become substituents. So our longest chain contains how many carbon atoms? It contains 6. And rule number 2 states we are supposed to look for the position of the double liaison. And the double liaison in this case is found.
Wait, Daliso.
Yeah.
I don't know if it's just me, but I've counted a chain that has 7.
7. Which one is it? 1, 2. Let's see. Let's count together.
Not the one that doesn't include double chain.
The one that does not
The double
include
bond. Sorry.
No. Good question. We are always supposed to prioritize the double liaison. At the end of this lecture, let me just go at the end. Let me just show you. There's a table at the end. You're supposed to master this table at the end. There's this table here. This is the table of priorities. So when you have an alkene and you have an alkene, the alkene takes priority. This is so if you have a carboxylic, the carboxylic acid is the highest. So if you have a compound and you have a carboxylic function, automatically that becomes a carboxylic acid. Now in our case, we have the chain ester is talking about is an alkene, Now we are saying the alkene has a priority higher than that of the alkene. So we are going to consider this one to be our function, and this here will be a substituent. So this is the order. So at the end of the day, you are supposed to master this table because it will help you when naming these compounds. So Esther, the reason why we are using the double liaison is because the double liaison is having a higher priority as compared to the alkene, So this is just like a summary of all these things we are going to study here in nomenclature. Is it clear?
Yes. Okay. Thank you.
Yeah. Thank you very much for the clarity. Yeah. So we are, where are we? Where is it? We are here. So we are saying the double liaison takes priority. Are there any questions before I continue? So we're saying the double liaison takes priority. So everything here, like I think she counted this one, 1, 2, 3, 4, 5, 6.
It's 1 o'clock.
1, 2, 3, 4, 5, 6, 7. She counted this one here, this one that goes like that. So this one here is an alkene because it's an open chain and has hybridization at sp2. Now we are saying the double liaison has priority over the alkene. So whatever is under the alkene becomes a substituent. So these things here will now become substituents. So this is our longest chain. So rule number 2 states we are supposed to position the double liaison. Now, question?
Yes.
Okay.
You said when we have a double bond in that organic structure, we have to prioritize it, right? But why didn't we consider it first in the first example? Why didn't we prioritize it?
Which example, boss? This one.
In that one, why didn't we start counting from the double bond?
No, we always start from counting from the double bond. As in, look, it's not always, what I mean when you start counting from the double bond is, which one has the lowest index possible? Is it the one that comes from this side or the one that comes from the, let me just show the diagrammatic representation. There is this direction we have here, and there is this other direction we have here. So now we are saying the double liaison is supposed to have the lowest index possible. Now, in our case, what's the lowest index possible? The lowest index possible is, if we count, we count from here, we count, say 1, 2, 3. It's found at position number 3. And on the other side, it's found at position, we can count from here 1, 2, or 1, 2. It's la même chose. The substituent becomes a methyl. So the substituent or the double liaison is found at position number 2. That's the lowest index possible. So we are actually prioritizing the double liaison because it has the lowest index possible. If the double liaison was found here, if the double liaison was found here, if it was found there, if it was found here, like that, and not here, and not this position, it's automatic that when we start counting from here. It's automatic that we start counting from here. We don't even have to look at the substituent, we start counting from here. Now, because this double liaison is at position number 2, so to just confirm, okay, which one is the lowest index, we start counting either from the left and from the right. Now, in our case, it is at position number 2, and 2 has the lowest index possible as compared to the 3 that we are going to have on the other side. So it is going to be called a pente de in. Pente de in. So is it clear, Mr. Who was that? Is it clear?
Yeah, it's clear.
It's clear, eh? So every time you have a
Yes,
double
yes.
liaison, so you have cases like this, right? Let me just go ahead again of the coup, just show you how we do nomenclature of these things. Now this one has a methylidene. Okay, I'll use this same example. So you see, we have a double liaison here. So automatically when we are counting, we are supposed to start from here. You start from here and go either in this direction. You also go either in that direction. So you always prioritize the double liaison. It is supposed to have the lowest index possible, the lowest index possible, the lowest, the lowest index possible. In the same way, this one has position number 1, 2, and this one also has position number 1, 2. So when you are counting again, you are going to now look at which one comes first in the alphabetical order and all those things. So we're going to look at these examples. Even here, when you're counting, we are prioritizing the double liaison. So this becomes our longest chain. This becomes our longest chain. And whatever is an alkene substituent, an alkene becomes a substituent. Whatever is a single chain becomes an alkyl, it becomes a substituent. So let's deal with this example here first. So we are saying this is our longest chain, and it contains 1, 2, 3, 4, 5, 6. It contains, and this answer is even wrong here. It's not dimethyl, but diethyl. So it's 1, 2, 3, 4, 5, 6. So it contains 6 carbon atoms. So if it contains 6, the suffix will be called hexa. The prefix will be called hexa. The prefix will be called hexa avec A. Then where is the double liaison found? The double liaison is found at position number 1. Mr. Who was that asking about this question? I want to know your name, boss.
Yeah, it's Fumbani.
Fumbani. Hey. So it's found at position number 2. So, position number 1. It's found at position number 1. So in a case where the double liaison was found on position number 2, if it was found on position number 2, we would have looked for the shortest route possible, either coming from this side, either coming from this side, either coming from this side, or coming from this side, because we are always going to consider the lowest index possible for any organic compound in nomenclature. So the lowest index possible is a 1. So, and we are saying for an alkene, we are always supposed to prioritize the double liaison. Now, in this case, at position number 1, and the terminaison or bien the suffix is ene, and the the a here and the e here have to cancel because that is 2 vowels that are repeating. So the a goes, and you have a 1 ene. So please, when you're naming these compounds, you're supposed to put my dashes. Just that when I was writing this polycopy thingy, I know how to do the thing, but you are supposed to put dashes like hex, tire, or be hyphen, 1 hyphen, ene. You guys have done nomenclature before, Tef. How many have done nomenclature before in Zambia? Even the basic one is nomenclature, same. You guys have not done nomenclature before.
Yes.
You've not done it.
No,
We have.
I have.
Okay. If you have, then at least you know how you write the name. So this is just poor handwriting. That's me. So you shouldn't fall for this because I know what I mean when I say die, and this is not methyl, it's ethyl. So I know what I mean when I just write to my hexnancan. When it comes to the exam, I know where to rectify and put the hyphen. So please, when you have names of compounds like this one here and showing position, you put hyphens. So you say hex hyphen 1 hyphen ene. So now we are also we are still on rule number 2. We are looking at the substituents now. So we are done with the position of the double liaison. Now we are going to look at the substituents. So the substituents here are found at position number, if we're saying this is our 1, there's 1 that is found at position number 2, 1 that is found at position number 2, there's 1 at position number 2, this one here, and the other one at position number 3, this one here, and another one at position number 4. So we said that we are going to go directly to rule number 4 that states we are supposed to align these guys in their order of alphabet, because we already know that the double liaison has given us the direction we're taking. The double liaison has given us the direction we're taking. So this is the route we are going to take. So this is position number 2, and we have an ethyl there. And position number 3, we have another ethyl there. At position number 4, we have a methyl. So to rule number 5 states we are supposed to use the multiplication factors. Now we have 2 ethyls here that are repeating, 2 ethyls that are repeating. So it's at position number 2 and at position number 3 that you have 2 ethyls repeating, and we are calling them di. We are calling them di. Sorry, this is not supposed to be methyl, it's supposed to be ethyl. Diethyl. At position number 4, you are supposed to put a comma for it. Oh no, it's not a comma, a hyphen. Supposed to put a hyphen here. Then at position number 4, you have 4-methyl. Then you end it with la chaîne principale. So the name becomes 2,3 diethyl 4-methyl hexane. Hexane. So when we start looking at functions, like functions in organic chemistry, functions also, depending on which function we are looking at, functions will also carry the same type of nomenclature, but with a different function here. So if we have an alcohol function, we are also supposed to position we're supposed to give the alcohol its position in the chain. If it's an aldehyde, the same thing. If it's an alcohol, the same thing. If it's a ketone, the same thing, etc. So these rules that we're applying for the alkenes, alkenes, they are the same ones we are going to apply for different functions. Like alcohols, I give an example, the carboxylic acids, the nitrites, and ketones, etc. So is this part clear? So rule number 1 is the chain principal, and we are saying the alkene is the one that is a priority greater than the chain over the alkene. So if it is a priority, we are counting from this and looking for the longest chain possible. We are looking for the longest chain possible. Now the longest chain we have found is this one here. The longest chain is this one. Now where is the double liaison located? The double liaison is located at position number 1. It is located at position number 1. And when you count everything here, we find that there are 6 carbon atoms. There are 6 carbon atoms. So these 6 carbon atoms have a prefix called hexa, a prefix called hexa. Then if they have a prefix called hexa and the position is 1, we are going to end the name with a suffix, and this suffix will be called in. In. The suffix is in. So the chain principal will be called hexa in. Hexa in. So the A here from the hexa and the E here cancel each other. The A cancels because it is a voyelle. Then we are still on number 2, where we are looking at now the substituents. We are done with the liaison. We are now looking at the substituents. So we are saying at position number 2, we have one substituent, which is an ethyl, and at position number 4, we still have another ethyl. At position number 3, we have ethyl. At position number 4, we have methyl. At position number 4, we have methyl. So therefore, the name will go as follows. So, like I said last time, the die does not count when you are arranging these alkyl groups substituents in alphabetical order. So E comes first in the alphabet, then you have the M that comes later. So we are saying because you have 2 ethyls, we are going to use the multiplication factor that is di. Therefore, the name of this compound will be called 2,3 diethyl. Here, sorry, there's supposed to be a dash. 4 methyl hexane. Hexane. Is it clear for this part? Okay.
Yes.
It's very clear. You have a question? You have a question? Okay. Yeah, what's the question?
Yes. So, based on this explanation that you have given,
Mhm.
is it safe to say that the principal chain must contain the shortest route to the double bonds on the carbon atom?
No. The rule is the longest chain should contain the double liaison, not the shortest, but the longest chain should contain the double liaison. So the double liaison is the one that is supposed to be prioritized. But in a case where you have, like the example we're going to, there are cases where you have a double liaison, it's short. The double liaison might look short as compared to this one. Let me just give this example as reference. When you see this one, the rule states, we are supposed to look at the continuous chain, the longest continuous chain. But now there's a remark here. The remark says, la chaîne principale est celui qui est la plus longue one. That is rule number 1. We said that's what we have been saying all this time. Et qui contient le maximum de double liaison. Now, this rule has now changed. It has now added another factor. If it contains 2 double liaisons, that becomes the longest chain, regardless having a chain of 20 carbon atoms. If you had 20 here, like 1, 2, 3, 4, 5, 6, 7 to 20, this is not our longest chain. Let me even draw it maybe to just give meaning to this remark. To just give meaning to this remark. Nice question, yeah? Madam, is it Madam? Who's this Madam? 1, 2, 3. What's the name of this Madam that has asked this question? You guys should tell me your names. So that you can try my question.
Blessing.
Blessing. So 1, 2, 3, 4, 5. See, like that. Just to give meaning to this question. So in a case where you had this as your hydrocarbon and you're told to name it, the rule number 1 states we are supposed to remark la chaîne principale is the one that is the longest, la plus longue, Now, normally, if it was the plus long, I would not have this part. If we do not have this part, we would have gone for 1 like that and gone like that because it's the plus long. But the question says, et contient le maximum de double liaison. So it no longer becomes the chain that has the highest number of carbon atoms, but becomes the chain with the highest double liaisons, That is, if there are two double liaisons, that becomes the chain principal. The chain principal must be the longest, and it should have two double liaisons. It should have double liaisons, two double liaisons. It must be long and have two liaisons. So it means if we have this chain here, we have this chain like that goes like that. This chain is the longest, It's the longest, yes, but it does not have the maximum double liaison. So it disqualifies this rule. It disqualifies this rule. But now, for us to qualify this rule, we are saying it must be a long chain, of course, and it should also contain the maximum, like the highest number of double liaison. So in a case where you have now a double liaison among these things, now you are going to also consider this chain. I think there's an example. Punta and Shuko is an example we are going to do. I think we are going to do this example to also just give meaning to your question, Madam Blessing. So is it clear? The rule states we are supposed to have a chain that is long, of course, a chain that's long. That is for all the cases we've been looking at. But that chain should contain the maximum of the double liaisons. It should contain the maximum double liaisons. In other words, what it means is that we are supposed to have a function to define this compound, hydrocarbon. There is a function that we're supposed to use to define this compound. And that function is what we are using as the suffix, is what we are using as a suffix. Is it clear, Madame Blessing? So the longest chain principal and contient le maximum de double liaison. Maximum de double liaison. So now, considering that we have this molecule or hydrocarbon, alkene, we are supposed to first of all look for the longest continuous chain, which is rule number 1. And the longest continuous chain, of course, was supposed to be this one going like that, or bien this one going like that. Now, there is another condition. Even if it's the longest chain, it's supposed to satisfy another condition, which is it's supposed to contain the maximum of the double liaisons. It's supposed to contain the maximum double liaisons. This is where now Esther's question comes in. Why didn't we take this part? It's because we are supposed to consider the one with the maximum double liaisons, and automatically whatever is not considered to be the maximum or does not contain the maximum of double liaisons becomes an alkyl group. So I said for our study in organic chemistry, we're just going to look at alkyls, but they are what we call alcenes and alcyls. I know the names look a bit the same, but they are different. So in our study, we are just going to look at alkyls. So in this case, this becomes an alkyl group. It's a substituent. It becomes a substituent. So now let's name this compound. We are starting from either we can start from this side or this is la même chose. La position reste la même. So we have position number 1, position number 2, position number 3, number 4, and number 5. So at position number 1, we have Mr. Fumbani. So we can start from here or from here. The position of the double liaison is what we are considering first. So if the double liaison was inside here, to just give meaning to Mr. Fumbani's question, we are going to position the double liaison inside here to just give meaning. Right? So if the double liaison was here, the double liaison, if the double liaison was here, sorry, something like that, and we do not have this one. We don't have this one. We have it here. Let me do it like this. So we have like a double liaison like that, another double liaison like that. So if the double liaison was at this position, automatically when we are counting, we start from this one here, because this one will have the lowest index possible. It will have the lowest index possible. Now, in this case, we have it positioned at the same place. We can start from this side. We can also start from this side. It still remains the same. But for this one, we have no choice. It's starting from we have to start from here and go like that. We start from here and move in this direction like that. Is it clear, Mr. Fumbani? It's Fumbani.
Yes.
It's Fumbani.
Yes.
Ah,
Yes.
okay. Yeah. Hope it's clear for everyone as well. So we are starting from position number 1 in this direction like that. So the principle is la chaîne principale, c'est qu'il le plus long et contient le maximum de double liaison. So we are counting in this order. That's going to be number 1, number 2, number 3, number 4, number 5. So a 5-chained hydrocarbon has a prefix penta, Now we have the double liaison positioned at number 1 and at position number 4. At position number 1 and at position number 4. So we are positioning at number 1 and number 4. Then the suffix is supposed to be in, which is A-N-E, c'est-à-dire at the end we are putting a E-N-E to just show that it's coming from the family of alkenes. Now we have 2 double liaisons. That is, we are going to use the multiplication factor, which is di, or bien D. So this becomes position number 1 and position number 4. We have a die in at position number 1 and position number 4. We have 2 double liaisons that are repeating, and we are going to conclude and say that that's a die in, because we have 2 double liaisons at position number 1 and position number 4. So we are done with the chaîne principale, which is made up of the prefix, that is 5 carbon atoms, and the positions of the double liaisons with the multiplication factor D and with the suffix ENE to show that it comes from the family of alkenes. Then we are going to look for the lowest index possible for the substituent. So starting from the bottom here, either we count here 1, 2, 3, c'est la même chose, or bien 1, 2, 3, c'est la même chose. So position number 3 becomes the lowest index possible for this substituent. Now I said, when you are counting a substituent, you do not start counting at say 1 here. No, you count from this one, 1. Because when you start counting and say 1, this one, it's like you're counting this carbon atom twice. You're counting this carbon atom twice. You're counting it for this long chain. You're also counting it for this continuous chain. And moreover, this chain is supposed to contain a hydrogen atom that is less. So when you start counting, that is going to be 1, 2, 3, 4, 5, 6. And we are calling a 6-chained alkene hexane. Now, when we remove 1 hydrogen atom from that, it becomes what? It's hexane. We remove a hydrogen atom, it becomes what? Hexane. We remove a hydrogen atom, it becomes what?
Hexyl.
Hexyl. It becomes hexyl. So we have hexyl at position number 3. So it now, therefore, becomes 3-hexyl penta 1, 4. diene. A4, diene. So this is the nomenclature for this compound. Please take note, la chaîne principale est celle qui est la plus longue et qui contient le maximum de doubles liaisons. Qui contient le maximum de doubles liaisons. Ça va? So same principle with these ones. So I just go to this, which one, which example? So choose between this example and this one. Which one should we do? This one or bien this one? Eh?
Last one.
The last one that contains a lot of carbon bonds, double carbon bonds.
No. We won't do all of them. We'll close the class now. You guys want to rest?
Yes,
No, there's someone that said both. The person that said both should be given an award. Why? Because you're supposed to understand how this one comes about and also consolidate on how this one comes about. So it's like you have a 50 kwacha in the road and another 50 kwacha in the road. Then others are saying, no, 100 kwacha, this is 100 kwacha, this is a 50 kwacha. Others are saying, we'll just get 100 kwacha and leave the 50 kwacha, it will be okay. But the other one says, no, let's get both, which is correct. So we are going to do both, this one and this one, to just give meaning to the question. Who said both? Is it Mutel?
Boss.
Mr. Ted, it was you.
It was Lillian.
Okay. Yeah, so the one that said both, that is a correct way of approaching certain questions. You don't just say, no, the longest. I know this one looks a bit complicated, but we target both. Both. So we are going to start with this one. Then we are going to finish with this one. So we are saying, d'après the rule that we're just from looking at time, this one. La chaîne principale est celle qui contient contient le maximum de carbone double liaison et la plus longue. So it contains the highest number of carbon atoms. It contains the highest number of carbon atoms. And it contains the highest number of carbon atoms. Why? Because it is being justified by the double liaisons. So whatever is different from this chain becomes a substituent. These things become substituents. So the double liaison is our guide. In this case, it's our guide. So Mr. Fombani Onko, we are going to start from either position number 1, this one, and this will be position number 5, or we are going to start from here and end here. It still remains the same. So at position number 1, we have a double liaison, and at position number 4, we have another double liaison. Now, before we even go to the liaisons and all those things, we are supposed to look for the prefix. The prefix will be number 1, number 2, number 3, number 4, number 5. So there are 5 carbon atoms. And the prefix for 5 carbon atoms, or for a 5-chained hydrocarbon, is penta. It is penta. Now, a penta is a 5-chained hydrocarbon. So at position number 1 and at position number 4, we have another double liaison. So at position number 1 and position number 4, we have a double liaison. So position number 1 and position number 4, we have a double liaison. Now, what is the terminaison, or bien the suffix? The suffix is ene. The suffix is ene. So rule number 5 states we are supposed to use a multiplication factor where you have 2 or more identical substituents, or bien 2 or more identical double liaisons, 2 or more identical triple liaisons, because whatever we are doing here will be applied on the ones for triple liaison. C'est la même chose. So when you start doing alcyls, I don't expect any problems because it's the same thing. Now we just have triple liaisons. So a triple liaison will also be considered to be a priority. Then you come to the long chain alkyls. Yeah. So for now, we are not looking at alcyls. We are looking at alkenes. So this is the position, that is position number 1 and position number 4. And we are saying rule number 5 is stating that if you have 2 or more identical substituents, or 2 or more identical double liaisons, or 2 or more identical triple liaisons, we are supposed to have a multiplication factor. And this multiplication factor here is a die, or bien a D. So we are saying now the suffix becomes a die-in, or bien a 3-in, a 3-in. So rule number 2, which also is rule number 2 for the double liaisons, states we are supposed to look for the substituents and give them position. Give them a position. Now we know that the longest chain is this one, right? The longest chain is this one. So now someone might ask me a question. It's okay, so you said we can start from this side like that, and we can also start from this side. Selami, I'm sure that's what you told Mr. Fombani, which is true. Now, when we are positioning the double liaisons for the substituents, now in regards with the substituents, we are supposed to now look at which one has the smallest index possible. So if we count, we start, we say, okay, 1, 2, 3. Where is the eraser? So if we count and we say 1, 2, 3, it's found at position number 3, 4. We have 4 there. So at position number 3 and position number 4. Then on the other side, we have 1, 2 at position number 2, and the other one at position number 3. So we have 2, 3, and 4. This is from this direction, which is this one here. Then from this direction, we have 2 and a 3. So between the two, which one has the smallest indices? It's 2, 3. It's 2, 3. This is the lowest index possible for this hydrocarbon. So even the nomenclature now will have a direction. So our direction is in this manner, Then we are going to go to rule number 4, which states we are supposed to arrange these guys in order alphabetic. So order alphabetic will be at position number 3, we have an ethyl. So E comes first. And at position number 2, we have a propyl. So 1, 2, 3, that's a propyl. So 1, 2, that's a methyl. A methyl. Is it clear for this question? So the nomenclature becomes 3 ethyl, 2 propyl, pent, comma. So there's a hyphen here. There's a hyphen. Penta, supposed to be penta, because there is no liaison. What do you call it? There is no vowel that you're going to cancel out here. Supposed to be penta, 4 die in. Sorry, so it's supposed to be penta, 4 die in. Is it clear for this question? Is it clear? We go. Okay. Okay, we go to this one. Alhamdulillah, alhamdulillah, alhamdulillah. So we go to this question. This question is a bit hard. We'll do it next week, inshallah. So we are saying the longest continuous chain should contain how many? The highest number of triple, double, or the triple, double liaisons. Now, in this case, which one consists of the highest number of double liaisons? Is it this one that goes like that? Is it this one that goes like that? Is it this one that goes like that? Which one consists the highest number of triple liaisons?
Yes.
There are two.
Which one is it?
The straight one. The
Straight
one
one.
that runs from 1. The one that runs from 1 to 13.
1 to 13, eh?
Yes.
But doesn't this other one also? Okay, I think there are two because
Which
there's
one?
this
There's
other one
one,
that's from the double bond.
1,
Then to runs one, they're like
yeah,
3 double bonds.
uh-huh.
Then there's so this other one that runs from 1 to 13. So I think there are two.
So
Okay,
now,
I think the
uh-huh,
one that's double bond and runs through to the right to 1. That's
the one that starts from the
the one
double
with
bond
the
and goes to the right.
yes,
Uh-huh,
yes to 1.
uh-huh. And there's another one that starts from
Yeah, there's one that starts from 1 and goes to 13, but I think that's that has the maximum is the okay. The one that we are considering is the one that starts with the double bond.
the one that starts with the double bond. Dave, now,
Yes.
okay.
No.
Now, no, okay. Uh-huh. What's the debate? What's the debate? Uh-huh.
The debate is
Okay, first of all, who are saying the longest chain is this one? Who are saying the longest chain is this one? Chill. Organic chemistry. Who's saying the longest chain is this one? I know some are saying this one is the longest chain.
Me.
How many are saying it's the longest chain? Come on, Maznan, you say your name and say, I'm considering this one is the longest chain. How many are considering this to be the longest chain? Uh-huh. Who else? Okay, that's Lillian. Then who are saying this one is the longest chain? This one is the longest chain. Who are saying this is the longest chain? This one. Who are saying this is the longest chain?
Me.
Me.
Yeah, Esther.
There is too much chongo, right? Yeah. So yeah, exactly. So this is the longest chain. Now we answer to Lillian's question. So the reason why this is not considered to be the longest chain is this same rule, right? This same rule here is what we are applying. The rule states that we are supposed to have the longest chain, exactly, and this long chain should contain the highest number of double liaisons. It should contain the highest number of double liaisons. Now, what Esther looked at, where are we? What Esther, oh, sorry, is it none? Who is it? Who is it? Please mention your name. Who was it? Who was it? Please mention your
It
name.
was Lillian.
So the reason why you said this was because you said the double liaison is supposed to come first. Exactly, which is true. It's supposed to come first. But now, is this chain the longest chain? Yes, it is a chain. It is long. Yes, it is long. But now, when you compare this chain to the other one here, this one, when you compare these two, they both satisfy the condition which states that it should be long and contain the highest carbon liaisons. Now, when you compare the number of carbon atoms, you find that this one has 13 and this one has 1, 2, 3, 4, 5, 6, 7, 8, 9. This one has 9 and this one has 13. Is it because you guys saw the answer, so you're saying this is the longest chain? Is it because you saw the answer, that's why you're saying try desection? That's why you're saying this is the longest chain?
No.
No,
just
No.
okay. Let me even increase maybe so that you don't see the answer, because some of you
So Daliso. So we don't have to follow this thingy whereby you have to start counting from where you've seen the double bond first, like the chain that has double bond.
This is where I'm coming now. The double bond is a guide. The double bond is a guide saying we are supposed to count from the double bond because that's the one that has a higher priority as compared to the alkenes. Now, in a case where you have a chain like this one, you've seen this chain. We are saying we are supposed to have a long chain, and that chain should contain the highest number of carbon atoms and should also contain the highest number of double liaisons. So now this is the case. This is our case. We have this one here. So if we count, this one has got how many liaisons? Triple liaison. How many are they? There are 1, 2, 3. Tef, there are 3. Tef, yo.
Yeah.
There are
Yes.
3. Then this one, how many are we having for this other one? For this
We
other
also
one,
have 3.
we also have 3. Eh? So it means they are at par. We have one that contains 3, and the other one also contains 3. Now, the rule states we are supposed to have the longest chain, and it should contain the highest number of triple liaison or double liaisons. Now, it already satisfies the maximum number of triple liaisons. Now, we are supposed to look at the other condition, which is it should be long. It should be the longest chain. It should be the longest chain. Now, this one has 1, 2, 3, 4, 5, 6, 7, 8, 9 carbon atoms. And this other one, either starting from this side or this side, we are going to say it's going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. No, this becomes our longest chain and the one we are going to use for our chain principal and the suffix and other things. Now, why? Because it is the longest chain and contains the maximum number of double liaisons. So this one is short because it contains 9 and this one contains 13. So 9 and 13, automatically 13 is more and 9 is less. So this one is considered to be our principal chain, even if we have a double liaison that is going to start here. Even if we have a double liaison that is going to start here. I said the double liaison is the beginning of this nomenclature. Like this is what we're supposed to use to say, okay, this is our chain that's going to go like that, all those things. But in a case where the double liaison does not satisfy the maximum carbon atoms, that is for the chain principal, and if it does not satisfy the number of double liaisons, the maximum number of double liaisons that you have in the compound, it is disqualified. It is disqualified. Even though, like I'll repeat, even though I said the double liaison is supposed to be your guide, here, normally, you guys, I think at the first instance, you guys went for this one because you're like, okay, it is or it has the number, like the maximum number of double liaisons. It has the maximum number of triple liaisons. But it does not satisfy the other condition, which is it is supposed to be the longest chain. Now, in this hydrocarbon, we have 2 chains. Now, one has 9 carbon atoms. The other one has 13 carbon atoms. So the one that has 13 is the longest chain and contains also the maximum number of double liaisons. Now, here is another question that can come in. Someone might ask me this question. Okay, then so what if there was no double liaison, but still 13? Now, this one does not become the chain principal. This becomes our chain principal. Why? Because it has satisfied our condition, which says it should be the longest and contain the maximum number of double liaisons. Because if I say or we remove this double liaison, we are going to have 1, 2 liaisons. And the rule is we are supposed to have the maximum number of double or triple liaisons. Now we have 1, 2, 3 for this one, and the other one only has 1 and 2. Therefore, if we did not have a double liaison here, our chain principal would have been this one here, like that. Is it clear, Madam Musonda?
Yes, it's very clear.
Alhamdulillah. So now we consider now counting our chain from either our left to our right or from our right to our left. Now, to just make things easy, like you guys, this is I don't know if it's the 4th time I'm talking about left, right. You guys now know where we're supposed to start from, because the lowest index possible here will be on the left, or on our right going to the left. So we count 1, 2 at position number 2, we have our double liaison. 3, 4, 5, 6 at position number 6, we have our double liaison. 7, 8, 9, 10 at position number 10, we have another double liaison. 13, 12, 13. Then at position number 12, we have another substituent. So we can go up like that, 13, or we can go down like that, 13. So la même chose. The substituent is still the methyl. Now, this is where I said that in your core for organic chemistry, you are not going to have such types of substituent. So this type of a substituent comes in as a result of this here. Can you guys see this here? It comes as a result of this. When you remove one hydrogen atom from an alkyl, from an alcene, you now have an alkyl alcyl, an alcyl, alcyl. You have an alcyl. So this here is an alcyl. That is the simplest alcyl that you have is methylidene or bien methyl. Now, because this one is a 2-carbon chain, 2 carbons, it's 1, 2. In other words, it's like a methane, it's like an ethyl line. It's like an ethyl, it's an ethyl. Now, the ethyl is in the form of a double liaison. Maybe just to simplify it like that, simplify it in that way. Or what happened is, we were saying methane, when you remove, methane is the normal name for the alkene. When you remove one hydrogen atom, it becomes a CH3. Then it becomes a methyl. So you remove the ANE suffix and replace it with YLE. It's the same thing. The double liaison is called ethene with ENE. Now, what you are doing is removing the E and E, not necessarily all of it, the E and E, but you are doing this. Let me show you with an example written here. Let me just show PowerPoint. This thing is kind of hard writing with a pointer. Can you see the PowerPoint?
Yes, yes.
So we're saying, okay. I'll be a bit fast here. So we're saying it's ethene. Maybe we start from here. Say it's ethane. Ethane. So it's alkyl group. Alkyl group will be called what? Ethyl. Why? Because we're only changing this termination here. We're changing this termination. We're changing this termination. We're replacing it with this termination here, which is this termination there. So this is our alkyl group. So now ethene we now have an now in French, it's written like this, right? In French, it's written like this. Our kins are written as with C, no, not with K. So if it's what do you call it? A substituent, you are going to also write it in this way. So the only thing that I've changed here is that the English one has a K and the French one has a C. So it's going to be an acyl group. Therefore, for ethene, it will be let's hope it's clear. Is it making sense? Is it am I shedding some light? Or it's too dark?
Yes.
Am I shedding too much dark or there's light? So let me just highlight what I mean with this terminaison. So we are saying this is our terminaison. So we are saying We are saying this is our terminaison TEF. So this terminaison ou bien suffix is what we are going to use. That is for the English. Now for the French, because you guys are now francophones, we are going to use this here. We are going to use this here. C'est la même chose. Even for propine. Propine. It will be what? Propyl. If it was an alkyl group, it would be propene. Propyl. If it is an alcyl group, it will be where is the P? Am I shedding more light? Then we want to go as far.
Now, how do you even pronounce because of the ends? Like, that's the only thing that's there. How do you even pronounce that word?
Like this one. Which one do you want me to read for you? Propyl. This is propane. Propyl. Propylene. Propylene. Like the even the way if you've seen the way we pronounce this is called Alcènes. Alcènes. So when you're pronouncing this, you also say proper guys. So I'm supposed to teach organic chemistry. I'm supposed to teach you organic chemistry. What's that pronunciation? Pronunciation is for you. So the way I pronounce it will be different from the way you guys pronounce it. So it's propylene, something like that. Propylene. Yeah. So for now, to just give, because in future, you might find a question, because this is the polycopy I'm using is what I'm also using for my organic chemistry. So in future, we are maybe going to find these things now. They are alcenes. The alcenes are the ones with sp hybridization, triple bond. So ethene, we start from here. It all starts from this one. Ethene is called. It's called what? Alkyl group. It's called ethyl. Second one is ethylyl. Ethynyl. The third one will be. It's the same thing. We are just changing cateminaison and adding this prefix. It will be like this. See, well. See, let me just confirm with my polycop. Sorry, guys. It's supposed to be in English. It's supposed to be this. No, let me just confirm with my polycopy so that I do not lie. So the spelling is C is ALCY N, like that. So this is the spelling now. So we are just removing, like I said, we are just removing this kapatupa. And we're just removing this kapatu. This kapatupa. Then we put Ethene. Becomes like that. Is it clear? So it means these are the substituents we are going to look at. For the alkenes, let me even put the names on top. For the alcenes, alkenes, like that. This is the order of substituents that you might find in future. Not napunzile, I've taught, even if it's just 1 minute. Napunzis. So now the pronunciation, like I said, please guys, pronunciation. I was taught to teach organic chemistry, not pronunciation. Pronunciation is for you. So what's it in this? Blessed pronoun what? Yeah, so that's the idea. The idea is you are just removing the, what do you call them? The suffixes and adding another suffix. Like this is ethane. So when we are looking at its alkyl group, it's going to be with the YL terminaison. We can also put E for the French. It can have the YLE terminaison. For the alcyls or bien alkenes, we remove the what is the prefix and add this terminaison. Just a minute. So this is what we are adding. This is what we are adding. This is what we are adding. Is it clear so far?
Yes, clear.
For everyone? For everyone? So now what happens is that question that we have in the exercise, there is what's this? An ethane. Now the ethane has a double liaison. Now the double liaison was subjected to a hydrogen, like hydrogen removal. What do you call the removal of hydrogen from a compound in organic chemistry? The removal of hydrogen from a compound and the addition of hydrogen to a compound, they are given names. The removal of hydrogen from a compound, what is it?
Oxidation and reduction.
Hey, who answered that question?
Esther.
What's the question? Okay, it's oxidation and reduction. There's another name for that one. There's another name I'm looking for. There's another name. It's very.
Dihydrolysis.
Dishan?
Dihydrolysis.
There's another name. That one is the removal of water from a compound. It's called dehydrogenation. It's called dehydrogenation. Dehydrogenation. And a dehydrogenation reaction can also be considered to be a redox reaction because there is a loss of hydrogen and there's also gain of hydrogen. So it can also be considered to be a redox reaction, or you can call it a dehydrogenation reaction. So what happened was the ethyl, which is a C, what's the chemical formula for ethene? Ethene with 2 carbon atoms. With 2 carbon atoms, we give the formula, this is CnH2n, like that. The formula would be what? Guys,
C2H4.
Now this is ethene. Now there is a hydrogen atom that has been lost. So we're saying mwanza. So CnH, sorry, where is H2 mwanza, H2 mwanza. So that will give C. I'm just removing one hydrogen. I'm just showing how the hydrogen is coming out. It will be CH3.
Yes.
Exactly. So
Yes.
this is now FU, alhamdulillah. So this is going to be called now our I don't know what you call this, but I know how I call it myself. So this is our substituent in that question when we're looking at the question we're looking at. So is it clear with the substituent and how they come about? Because I'm pretty sure as we go on, we find some more substituents. And you asked me on there, so how did this come about? So this is just like a brief explanation of how the substituent come about and their names. Is it clear?
Yes.
Yeah, okay, you have a question?
Yes.
Yeah,
With the pronunciation?
On the, what's this? On the previous example, we're just from having. I'm a little bit behind why we found one on the position of the double liaison. That part 160, right?
No, we're not even done with the nomenclature. And I was just showing you the name of the substituent that we have in the question. We're not done with the nomenclature. Don't worry, we are still going back there. Then we close. We'll continue at 15. Don't save.
Okay.
Yeah, I'm still going back there. I was just showing you what we are looking at. Can you guys see the presentation now? This is what we're. Can you see it?
Yes.
So what we're doing there is this. Those are things where we're moving to my hydrogen atoms. FUF. This is what they're doing. This is what now they are just explaining here. Right? So when it's a methyl, it's called a methylidene. When it's an what do you call it? When it's a methyl, it's called a methylidene or methylene. Then answer the suite. The pronunciation is yours, you guys. I'm only here for organic chemistry. So we are saying the chain principal. The chain principal is this one. The chain principal is this one. So now we answer the question. We are saying this becomes our chain principal, and we are going to use this direction here. Now, why are we using this direction? Because the lowest index possible for this double liaison is at position number 2. Now, when you compare it to the one on the other side, it's at position number 1, 2, 3, at position number 3. So this one here automatically has an index lower than this one here. So number 1, number 2, number 1, this is number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8, number 9, number 10, number 11, number 12, number 13. So we are saying at position number 1, I even made a mistake in this square. It's supposed to be 2, not 1, 2 here. 2, not 1, right? 2. So at position number 2, we have a double liaison. At position number 6, we have another double liaison. At position number 10, we have another double liaison. So now the number of carbon atoms is 13. So it's going to be called a 3-deca, whatever, decanoate, all those things, but it's a 3-decane. So a 3-decane is a 13 carbon chain. Then our positions, we said it's not 1 but 2, 6, and 10. So at position 2, 6, and 10, we have double liaisons. At position 2, 6, and 10, we have a double liaison. Now we are saying the suffix will be called E and E to show that this is an alkene. Now, like I said, because we have 2 or more identical substituents. Now, in this case, we do not have substituents. Okay, we do have substituents, but we have also multiple liaisons. Now, we have 3 multiple liaisons. Now, these 3 multiple liaisons are supposed to be shown with a multiplication factor, which is a 3 or bien tri. So, therefore, it will be tri, deca, 2, 6, 10, tri, in. Is it clear on the chain principal?
Yes.
Alhamdulillah. Then, now we go, it's clear? Now we go to the chain principal. Now the chain principal, like I said, at position number 7, we have a substituent. Now this substituent is an alkene with a double liaison. It has a double liaison. Now there has been an arrangement of a hydrogen atom. There's one hydrogen atom that has been removed from this substituent, and it's now going to be called. Someone to pronounce this word for me.
Ethene.
Ethene?
Ethene.
Ethene.
Ethenyl. Voila. Those people that were asking for pronunciations, it is ethenyl, Monville. Ethenyl. So it will be ethenyl. At position number 12, we have a methyl, and it is done. So the nomenclature would therefore be set ethenyl 12 methyl 3 decene, with position number 2, number 6, and number 10. With position number 2, 6, and 10. Then the name can also be written in this format. It can also be written in this format. Now, E format is what we are calling the format of nomenclature with the nom usual. You guys know what vinyl is? What is vinyl? Vinyl. Where did you hear the word vinyl? Where did you hear it from? Vinyl. Where did you hear this name from?
PVC.
Exactly. Vinyl chloride, is it chloride? Yeah, polyvinyl chloride is a PVC. It's a polymer that is formed from the ethenyl or bien the vinyl function. So the other name for ethenyl, like you guys said, it's ethenyl, is vinyl. This is the nom usual. The nom usual is like a common name, like a nickname that we give these compounds. Like ethanoic acid can also be called acetate. Ethanol, the one that is found in alcohol, can be called ethyl alcohol. So these are the names they're like nicknames. When I say nom usual, it's like a nickname for a compound or for a hydrocarbon. So in this case, the vinyl is a nickname for the ethenyl. So like rule number 4 states, we are supposed to arrange them in order alphabetic. Now, what comes first between M and V? It's M. I'm asking.
Yes.
It's M. So it's going to be position number 12. Then we have a methyl. Position number 7, we have a vinyl. Then the nomenclature follows NC the suite. Becomes 3 deca.
How do you know if it's a vinyl?
How do you know it's a vinyl? It's going to have, where is it? Vinyl. So a vinyl is what do you find? The formula. Let me go back to my PowerPoint. Or maybe I should just explain from here. So we are saying the general formula for an alkene is general formula is CnH2n. CnH2n. And the first one, no, this is the second one. The second one is called Ethene. Now, when we remove one hydrogen atom, it now becomes ethenyl. It becomes ethenyl. Now we are saying, certain radicaux alcyl sont des noms usuels. So how do you know when you have this type of arrangement in a compound? Then you know that, okay, this is an ethenyl, and an ethenyl is also known as a vinyl. So you can either replace ethenyl with vinyl, or you can just maintain the ethenyl. Let me just show you examples that we're replacing ethenyl with. I think the quiz is done. I'm just showing an example of compounds that were replaced with ethenyl and vinyl. Where? Like this one. Like this one. You see, we call this thing vinyl benzene, but it can also be called ethenyl benzene. It can also be called sterylene. Now, sterylene is the nom usual. The nom usual is sterylene. So you can call it ethenyl or bien vinyl benzene. It depends on what you want to call it. Is it clear? So we are going to look at these things later on. I was just showing you where maybe it can come in handy. So we also have these arrangement of hydrogen atoms. It doesn't only end on the methane or the ethane, the alkenes, alcenes. It also goes as far as the arenes, where you have hydrogen atom is removed and you have Ephenyl. It continues, right? You have toluene, you have all those things. So unfortunately, we're not going to look at nomenclature in aromatic compounds like their derivatives. We want to look at benzene, then we go on, because a lot of things we're supposed to do. Nomenclature is too long. Yeah. So that is it with the vinyl. Any other question? So when we come back at 15, we are going to start nomenclature of these things now. Where are we? Over. This is Alcènes. We're going to start the nomenclature of triple liaisons. Triple liaisons. Then la semaine prochaine, inshallah, we are going to start on the cycles. But on the cycles, I think I'll even touch some to the sort. When we come back, it's something else. So if there are no questions, 15 hours there is analysis. Now, what are we going to do? Because what happened was Mr. Dilax told me that I should take